Alright, so in this video, we're going to go through sample question 64 from the Society of Actuaries ExamP list of sample questions. The question reads, a probability distribution of the claim sizes for an auto insurance policy is given by the table below. And get a nice little table here giving claim sizes as well as the probability of that claim size. So this is clearly a discrete distribution. We need to calculate the percentage of claims that are within one standard deviation of the mean claim size. All right, so on its surface seems like a pretty easy problem. Hopefully it stays that way as I work through it. Now, we need the probability that claims are within one standard deviation of the mean. That kind of implies that we need both the standard deviation and the mean. So the mean is simply the expected value of x. And the expected value, as you should know, is the sum of every value multiplied by the probability of that given value. So let's work on that. This gets us the expected value. And what's really nice about a table like this, if you get a table like this on the exam, it is a gift because here's the value, here's the probability of that value. Easy information to work with. This is now equal to 20 multiplied by 0.15 plus 30 multiplied by 0.1 plus 40 multiplied by 0.05 plus 50 multiplied by 0.2 plus 60 multiplied by 0.1 plus 70 multiplied by 0.1 and plus 80 multiplied by 0.3. And this will just take me a bit to do on the old TI 30XS. So just give me a moment. Now, I typically try not to do these problems ahead of time. I think it's important for you to actually see me work them out the way you would on an exam. And this question seems to be largely a calculator it's testing on whether you can use a calculator, okay? Not too difficult. Just give me a moment. Okay, and we get a value of 55 as our expected value. Next, we need the standard deviation. Now, you should be familiar with this simple formula. The standard deviation of x is simply equal to the square root of the variance of x. And what's the variance of x? Well, the variance of x is the second moment, also known as the expected value of x squared, minus the first moment, which is the expected value of x, and that squared, where the square's on the outside. All right, luckily we already have the expected value. We just need to now get the second moment. So I'll just have to set up a new equation, and that's going to be another little bit on the calculator. So the expected value of x squared, which is equal to 20 squared, and once again times the 0.15 plus 30 squared times 0.1 plus 40 squared times 0.05 plus 50 squared times 0.2 plus 60 squared times 0.1. If this is seeming a bit messy, because it is, just know where I'm getting the numbers from, which is the chart given to us here. Okay? And this, again, I just plug into my calculator. If you want any clarification on these numbers or how I'm actually calculating expected value of x and x squared, by all means, leave a question down in the comments. I will clarify as best that I can. Okay, got it. Yep. So that is going to be equal to 3,500. All right, so we have the expected value, we have the second moment. Now we can actually calculate standard deviation. Standard deviation of x is equal to the square root of 3,500 minus 55 squared. And that ends up equaling, again, just an easy thing to punch into the calculator, 55 squared, 5 rad 19, or approximately 21.79. However, for calculations, I suggest using the 5 rad 19 that the calculator will give you. I'm always really nervous about rounding errors, especially nervous about rounding errors for FM, because it seemed like when I was practicing that, that's where most of my mistakes had come from after a lot of practice. But I mean, again, it's probably not going to make a difference. I'm just paranoid about that. So what's next? We want to find the probability that we're within one standard deviation of the claim size. So we're looking for the following: probability of x being with like one standard deviation below, right? So that's going to be 55 minus 5 rad 19 is my lower bound for x, and we're also 55 plus 5 rad 19. Okay, and simplifying that down, we're looking for x being in between 55 minus 5 rad 19 is 33.2. So that's my lower bound, and my upper would be 76.79. Okay, so we want to find the probability we're in between these segments. Now, this comes back to, if you get a chart like this, you're super lucky, because the probabilities are given down here for a discrete distribution. So which values fall into this range? 40, 50, 60, and 70. And all we got to do is add those probabilities up, right? 0.2 plus 0.5 is 0.25 plus 0.1, 0.35 plus 0.1, 0.45. And that gets us answer choice A. All right, simple as that. So just a brief overview. We're given a chart with a discrete distribution and the actual probability for that. Great. That means no trying to figure out something from a density function to get the actual probability. We're asked to find percentage claims within one standard deviation of the mean. That requires us to actually get the mean, get the standard deviation. I calculated the mean with the basic equation. I understood standard deviation is the square root of the variance, so I calculated the variance, square rooted that, got the standard deviation. And then I figured, okay, the probability of being within one standard deviation is as follows here. And I figured out, okay, one standard deviation below the mean is 33.2. One standard deviation above is 76.78. My discrete values that fall in that range are listed here. So the probability of being in that range is the sum of their individual probabilities. Okay, admittedly a bit long-winded explanation for, a simple question, but just can't help myself. If you have any questions, leave them down in the comments. I'll answer them to the best of my abilities. I've got a playlist on this stuff if you want to see more questions. The Society of Actuaries is sample questions. And if this video helps you out, hit the like button, subscribe, because that totally helps me out. But other than that, good luck.